So believe it or not, this is actually the last lesson in the trig unit because, again, as I said and have said, dealing with trig with degrees is very simple. Dealing with trig with radians is significantly more complicated. So what we're going to do right now is we're going to work through this last Walsh lesson here. So we are on page 231 here. So go ahead and go to page 231 and we're going to get started. So anytime you are given some sort of word problem, you've got to draw the figure. You don't need to be an artist, certainly, but you need to at least show a vertical, horizontal, and a diagonal. So it says the height of a tree is 15 meters. So that's going to be my tree. Again, I'm not going to create an actual tree because I don't want to draw, but I know that a tree, oh, that's interesting, is a vertical. So I know that as I'm working through this, I know that my tree here is going to be 15 meters. Now, the next thing it says is to the nearest whole degree, what is the angle of elevation? All right, so that is one of the two terms that we're going to be talking about today, the angle of elevation. And the angle of elevation we'll see in this image is also congruent to the angle that we're going to be talking about later, which is called the angle of depression. But the angle of elevation and the angle of depression, again, are congruent angles here. So it says it wants to know what is the angle of the elevation of the sun when the tree casts a shadow that is 9.3 meters long on the level ground. So we know that all right, so for some reason, this board is just like being absolutely horrendous today. So sorry, guys, you're going to have to be patient. So again, it gives us a wow, this is going to be a long situation. Gives us a horizontal there where our value is 9.3 meters. And what it's asking is for the angle of elevation of the sun when the tree casts this shadow. So we know that we have a sun somewhere. Doesn't really matter where it is. There's a sun. Oh, wow. I don't even know why the board is doing this. It's never been a problem before. All right, so there's our sun here, and we are trying to find the angle of elevation. So we're going to draw our hypotenuse, our diagonal here. And there we go. So we've got our diagonal here. So now we need to talk about the angle of elevation. So there are two different angles that we're going to be talking about, the angle of elevation and the angle of depression. But basically we have parallel lines here and here. So the angle of elevation is always going to be the angle right here. It's going to be the angle that kind of shows from the ground how, like looking up at something, what that level or what that angle degree would be. And then also the angle of depression then, so this is up here is our angle of elevation. And then the angle of depression is the angle that if you're up here, it's the angle that kind of that you're looking down at. And so it's kind of like if you are looking, like if your eyes were right here and you were sort of looking and saying like, what angle would you be looking down here? So the angle of depression here is this angle. And it is the alternate interior angle to the angle of elevation. And we know that alternate interior angles are always congruent. So if you know the angle of elevation, you also know the angle of depression because it's the same thing. So right there we have our angle of depression. So in this question, they are asking us to find the angle of elevation. So they're just asking us to find this angle. So when we are thinking about our trig functions, we are looking for this angle. So this is the one that is opposite it. And if I'm talking about this angle, that's opposite, and then this side length would be adjacent. So if we're thinking about our trig functions, that's SOHCAHTOA. That means that if we have opposite and adjacent, we want to use tangent. Now, anytime we are finding an angle, remember we're not just using tangent, we're using the arctangent. So when we use our calculator, we have to hit second tangent. So we want the arc tangent of the opposite over the adjacent. So here the opposite is 15 and the adjacent is 9 3/10. So again, you want to make sure that your calculator is in degrees. So if your calculator is in radians, you're going to get the wrong answer here. And for angles, let's go ahead and just round these to the nearest tenth. So when we find the arc tangent of this ratio here, we get that the angle of elevation must have been 58.2 degrees. All right, so hopefully that makes sense, and that is what the angle of elevation is. And again, which function you use will depend on what information you're given. So we're going to go ahead and look at number 2 now, where we're going to have to draw another image here. All right, so in this question, it tells us that a meteorologist is reading a radio signal from a weather balloon. So we're going to have some sort of balloon up here. I'm just going to draw a circle. That's my balloon, because that's what I want my balloon to look like. So I've got my balloon up here. It's my radio, my weather balloon. Information's coming from here. It says the last alert indicated that the angle of depression of the weather balloon to the meteorologist was 41 degrees. So, and it says that the balloon was 1,810 meters away from its location on the diagonal. So what that means here is if this is where our balloon is, we know that we're going to be dealing with a right triangle because this is our trig unit. So we've got our balloon, and then we've got our right triangle. So let's start filling in some stuff that we know here. So it tells us that the diagonal is 1,810. So we know we're going to be dealing with the hypotenuse because we have that. So we're going to be using either sine or cosine here. And it tells us that the angle of depression was 41 degrees. So again, the angle of depression is congruent to the angle of elevation. So the angle of depression is this one right here. So again, angle of depression, this one right here. So this is going to be 41 degrees there. And then we know that. So now it wants to know how high the above the ground was the balloon. So we're looking for that value here. So one of the ways that you can look at this is to recognize that the height here would be the same as the height here. So you could use the angle of depression as the angle and then deal with your side lengths that way. But the way that I tend to deal with this is always just to know that since the angle of depression is equal to the angle of elevation, that since this is 41 degrees, that this is 41 degrees down here as well. So what I'm going to do now is I'm going to think about what I know. So I know this is 41 degrees. I'm trying to find this height. Well, this is the opposite here, and this is the adjacent. No, it isn't. That's the hypotenuse. So if I have opposite and hypotenuse, I'm going to use the sine. So the sine of 41 degrees is going to be equal to the opposite x over the hypotenuse, 1,810. So here, when we solve for x, the only thing that's going to happen is, wow, I wonder why this is happening, is that x is going to be equal to sine of 41 multiplied by 1,810. So when we take the sine of 41, and again, calculator's got to be in degrees, and multiply by 1,810, we get that our value of x, and does it tell us what to round to the nearest meter? So is going to be 1,187. So the height here is 1,187 meters off of the ground there. So if we had done it the other way, if we had dealt with this, then we know that this side length here, so we deal with this side length here. So we'd be looking for this. So this would be, again, opposite over hypotenuse. So again, there we go. So I hope everyone is good on that problem there. And, oh, there is one other way to do this. Technically, you know that this here is going to form a right angle since these are parallels. So if you know that this is 41, you know that this is 49. So you could have also done the cosine of 49 is equal to the adjacent x over the hypotenuse. So again, just a couple different ways to address that question. All right, so let's go ahead. And again, this is just looking here. Things to remember: the angle of depression and the angle of elevation are always congruent. All right, moving along here to example 3. So in example 3, the image, and in example 4 as well, the image is already here for you. So it says the sonar operator creates basically this image. And it wants to know what is the angle of depression from the cruiser to the pod, and what is the distance y from between the cruiser and the pod. So first thing is the angle of depression here is actually this angle right here, because the angle of elevation from the dolphin pod up to it would be this angle here. So this is the angle of depression right there. We just need to find it. So we know that we're looking for this angle, and we have the side length that is opposite it and also the side length that is adjacent. So if we have the opposite and the adjacent and we're looking for an angle, we need to use the tangent, but we need to use, because we're looking for an angle, the arc tangent. So I'm going to take the arc tangent of the opposite, which is 255, over the adjacent, which is 450. And when I solve that out in my calculator, I get, let's round to the nearest tenth again, I get that the angle of depression from the cruiser to the dolphin pod there is 29.5 degrees there. So now we know that this angle here is 29.5 degrees. Now, of course, we could use the Pythagorean theorem here to find the value of y, but because this is our trig unit, we're just, again, going to challenge ourselves to not do it that way. So let's go ahead and find y there. So if we're looking for y, we know the opposite, and we're looking for the hypotenuse, and we know the adjacent, and we're looking for the hypotenuse. So I'm just going to use cosine because we haven't used cosine in a while. So I know if I'm using the cosine there, I know that the angle is 29.5. So the cosine of 29.5 is going to be equal to the opposite over the adjacent. So the opposite, the adjacent over the hypotenuse. That would be, why are you terrible? Okay, well, we know CAH. Wow, okay, that was traumatic. So the cosine of 29.5 is equal to the adjacent, which is going to be 450, over the hypotenuse, which is x. So at this point, or technically it's actually y, but same thing. So we now need to solve for that distance there. So when we cross multiply, we get that x multiplied by the cosine of 29.5 is equal to 450. Well, anytime I solve for x, this has been true since 6th grade, I divide if something's being multiplied and it's attached through multiplication. So I divide here by the cosine of 29.5, and that is going to give me that the distance there, which is y, even though I'm using x, which is annoying, sorry, it gives me that the distance there ends up being rounded to the nearest tenth. It ends up being 519.6 meters. So that diagonal distance there, the value of y is 519.6. So that is the end of example 3, and let's move on to example 4. All right, So in this next problem, there's going to be three parts here because we're going to have to find an A, a B, and a C. But this whole situation here has just been turned into this picture here. So you can read it if it brings you joy, but we're just going to move right along. So it says, use the information to solve for the base of the top triangle to determine the distance from the observer's eye level to the wind turbine axis. So it's basically asking us here, it wants from the eye level to the base of the turbine axis. So it's asking us to find A here. So if we're thinking about this top triangle here, we actually do know one of the side lengths, even though we think that we don't, maybe initially, but we know that if the entire distance, the entire vertical distance is 250, that this portion of the vertical distance has to be the difference between, and that's not 250, that's 205, but has to be the difference between 205 and 160. So that means that our vertical distance of this top portion here is just going to be 45. So as I am looking at this problem here, I know that I have this angle, I know the opposite, and I'm looking for the adjacent. So to find A here, I'm going to want to use tangent. So I know that the tangent of 28 degrees is going to be equal to the opposite, which is 45, over the adjacent, which is what we're looking for, the value of A. So when I go to solve here, I cross multiply, and I get that A multiplied by the tangent of 28 is equal to, so we have that A multiplied by the tangent of 28 is going to be equal to 45. So again, to solve here, we need to divide by the tangent of 28. And that's going to give me an A value there of about, let's round to the nearest tenth again. So that would be 84 and 6 tenths, so 86.4. So we know, 84.6. So this one here is going to be 84 and 6 tenths. So we now know the value of A. All right, so the next thing that we're going to do is we are going to find the distance from, oh, it says to the nearest meter, actually. So I guess we can just make that 85. That looks beautiful. All right, so we now know that the value of A is 85, and the next thing that we're going to look for is the value of B. It wants the distance from the eye level to the base of the turbine. So from the eye level to the base of the turbine there, knowing that the tangent of A there was 84.6. And when I put that, that's 85. All right, so now we're looking for the value of B here. Well, when we go to find the value of B here, we are going to have to use the Pythagorean theorem, because in order to find this using trig, we would have to know the value of that angle, and we don't know the value of that angle right now. So again, not enough information for us to do anything but Pythagorean theorem. So to find that distance there, and sorry, these aren't going to line up to what it says here, but to find that distance there, so I know 85 and I know 160. So I'm trying to find the hypotenuse, which is the value of C, and I think that's 60. No, it is 85. All right, so we're going to find the value of C there by doing A squared plus B squared is equal to C squared. So A, we are just going to use that value of 85, so that's 85 squared plus 160 squared is equal to C squared. So we're going to just round to the nearest meter again, so go ahead and solve there. And that's going to make that distance there 181 meters. So we know that the value of B now is 181 meters. So the last thing that it wants us to know is what is the distance to the nearest meter from the observer's eye level to the tip of the rotator when it reaches its highest point. So now it's just asking us to go from this eye level up to the highest point there at the rotator's tip. So again, that one there is 45. So we know the value of this angle here. So we could either use sine or cosine because we know the adjacent and we're looking for the hypotenuse, and we know the opposite and we're looking for the hypotenuse. So let's go ahead and use whichever one you want. I guess I'm going to use sine. So I'm going to set up there that the sine of 28 degrees is going to be equal to the value of the opposite there, which is 45, over the hypotenuse, which I don't know, so that's going to be C. So I know that C multiplied by the sine of 28 is going to equal 45. So I know I can divide by the sine of 28, and that gives me the value of C there, which is going to be rounded to the nearest meter, 96 meters. So we go up here, and we know now that the value here is 96 meters. Now, if we wanted to find this angle here, we absolutely could, because we know enough side lengths, so we could use any one of our arc functions to find the value of that angle, but again, we're not so worried about it. So at this point, let's talk about what you're supposed to do to review this. And again, so right now, go ahead and turn in your Walsh book there. And for your homework, you're going to be doing just practice A, so page 235, 236, 237, 238. That's just a lot of words. It's not so much a huge assignment. It's just 10 questions. So please do that so that you have some practice there, because what's going to happen tomorrow is you're going to go into Canvas and it'll be the first practice test for the trig unit. So you're going to complete that, submit that, and then what I'll do is just what I did last time is I'll make a video that goes over all of the different questions there, and you can watch that, and then you will have the opportunity, you will then take the second one that on Friday, and then next week we'll actually move into our study of probability, which is the very last thing that we're going to do. So hopefully that makes sense to you. And again, when I post the first practice test, I'll also post a video that goes over the solutions to this assignment, the homework that you're doing in your Walsh book, so that you can check that. So again, reach out if you need anything, but hopefully this made sense. Bye.